Hi everybody. We're going to do the TRex runner game. We're not just making the game though. This is an opportunity to practice the important kind of thinking that I talked about last time. I said that programmers fit larger, more complex programs into their heads by breaking them into small parts that interact. So that's what objects are about, and that's what methods are about. It's figuring out how to decompose your game into these interacting pieces. So that's what I want you to be thinking about as you play TRex Runner for the next 2 minutes. Think about what objects will this game have and what variables and commands do they need to respond to in order to be able to do the things that you see in the game. A common pattern in a lot of these games, and one that we used in Foxes and Rabbits, is there's a single class that's sort of like the God class that has all the objects in it and that micromanages the behavior of all the objects. So here's the kind of thing I mean. In Foxes and Rabbits, that was called Simulator, and it had lists of all the animals, and as you remember, we loop over all the animals and we tell each one to act. It also has other objects, so it had the field display object, and after telling all the animals to act, it would tell the field display to draw the field to the screen. So any little thing that happens from one frame to the next is something that Simulator will order the other objects to do. So that's the same kind of thinking that we want to. Here you see the TRex Runner game. And if I look at the objects, well, clearly there's a T-Rex, and it seems like there's cactuses. Looking in the background, I see clouds, I see the ground, and maybe it's not clear whether or not the ground should count as an object. So let's just start with the T-Rex and the cactuses. I'm going to stop playing because I can't think and play at the same time. So usually if I ask people, what commands do you think that the T-Rex object needs to have? They say, well, he needs to be able to jump and duck, because they're thinking from the perspective of a player. And you're right, the T-Rex does need to do those things. But if you think about being sort of the God class for this game, which we'll call game, you need to be able to tell all of the objects all of the little things that they're going to do for every single frame. And that includes a lot of stuff that wouldn't occur to you as a player. So for example, maybe the game needs to loop over every cactus object and tell it to move a little bit, then tell it to draw itself to the screen. Then it needs to tell the T-Rex to check if it's touching that particular cactus, and the T-Rex will answer yes or no. And if the answer is yes, then the game actually tells the T-Rex to set itself to dead. So what I'm getting at here is nothing happens without going through the game. T-Rexes don't check themselves to see whether or not they're touching cactuses. The game tells the T-Rex to check if it's touching a cactus. And when the T-Rex is touching a cactus, it doesn't decide that it's dead all on its own. Instead, it reports back to the game, yes, I am touching a cactus. And then the game decides what happens by telling the T-Rex what to do, and probably also telling other objects in the game what to do. So that's the perspective you need to be thinking from. What are all of the little things that every single object in the game need to be able to do if this kind of God class that's micromanaging everything is going to be telling them what to do? So in class, we did a little exercise where I had people just brainstorm what the variables and methods are for an object. Just as a little reminder, what it looks like to use an object, way back when we worked with turtles. So you can create a new turtle by saying new turtle, which runs the turtle constructor. Then there were two different kinds of methods. So there were methods that tell an object to change something about itself. So yurtle.goForward is telling the turtle to change its own x-coordinate. There are also commands that let you ask a turtle something about itself. So here I'm saying yurtle.getY-coordinate, which is me saying, hey, would you please tell me what your coordinate is? And it will give me back an answer. So we need both of those kinds of methods in our game. I just said for TRex Runner, like the T-Rex object, we'll need to be able to tell it to jump, for example. We'll also need to be able to ask the T-Rex object if it's touching something else, so that we can tell it that it has died. So that second one, asking if it's touching something, that would be sort of like a getter method, because we're asking to get some information from the object itself. So what I would do if I were you is open a document, use this format. So don't call it turtle, you're going to call yours cactus. But then imagine, what are the variables that a cactus needs to have? and what are the commands that a cactus might need to respond to. So make your list. It's probably pretty good, but you're probably also going to miss some things. And I think that you're going to learn more if you try to make the list yourself first before seeing what it was that we all did. Okay, so pause now. Fair warning, I'm about to show you. So this was a little bit different in the different blocks, which is fine. In 7th block, we decided that a cactus needs an X and a Y coordinate. It needs a width and a height if we're going to decide whether or not it's colliding with the T-Rex. We decided that some people gave the cactus a color, but that doesn't really make sense if you look at the game. The cactuses don't really have a color. Instead, they're little pictures. So I told everybody that p-image is the data type we're using for an image, and that every cactus is going to get its own image for displaying itself. People decided that maybe it also needs an x-speed variable that controls how fast it moves. The last thing that we need is a screen object, because we're actually going to have the cactus draw itself to the screen. The same way that the simulator told the rabbit to act, we're gonna have our game tell the cactus to draw itself on the screen, so the game doesn't have to do that itself. But if the cactus is going to draw itself on the screen, it actually needs an object that represents the screen, which it can tell, like, I'm going to draw myself onto your screen now. So that's what this is. A p-applet, if you remember, is a data type that means a graphics window, and I've named the variable screen. Okay, in terms of commands that a cactus needs, I said that a cactus should be able to draw itself, so draw is one. We talked about having a move method, and we debated two different options. One option would be the cactus doesn't actually have a speed variable. Instead, you give it like a number of pixels that it's going to move as an input to the move method. So whenever the game tells a cactus to move, it'll say, hey, move 10 pixels, or like move 8 pixels, or whatever. A different way of doing it is the move method doesn't take any input at all, and the distance that it moves the cactus is whatever distance you have up here in x speed, which is a number that you would set inside the constructor when you first make the cactus. I think either approach is okay, and there are kind of pros and cons to either one. We decided one really important thing that we'd need to be able to take care of is if you play the game for long enough, everything speeds up. So no matter what speed approach we take, we need some way of telling the cactus to speed up. So for us, we decided to keep move with no inputs, and we said increment speed was a method that we were going to use to have the cactus increase its own x speed. We decided we need maybe a get x and a get height and a get width, because at some point somebody's going to need to ask the cactus where it is to figure out whether or not we're touching it, or whether the T-Rex is touching it. So we might end up changing some of these along the way, but this seems like a pretty good first shot at it. So let's think about T-Rex now. For the T-Rex, we decided it needs a lot of the same kinds of things. So it needs an X and a Y and a width and a height. It's going to draw itself onto the screen, so it actually needs a screen object. We figured out, actually, the T-Rex doesn't need just one image, it needs a bunch of images. Because, like, you can see his little feet running there, his little feet pitter-patter. So that's actually two images of the T-Rex that are swapping back and forth. So that's what standing 1 and standing 2 are. It's those two images. And then he's got maybe two crouching images. And somebody pointed out there's an image that's different that he looks like when he's dead. Both feet are down and his eye is kind of open wide there. Well, maybe not dead. He just walked into a cactus. So maybe we'll say stunned. But the point is your T-Rex will probably need to have several different images. And when the T-Rex draws itself, it will need to decide which image to use when drawing itself. We thought we probably wanted like something like jump strength. We don't know if this should mean like jump speed or jump height, but some way of controlling kind of how high the T-Rex is going to jump. And we decided we probably also want to keep track of whether or not the T-Rex is alive or whether or not it's touched a cactus. So in terms of commands, we want draw, and we also want jump. You'll see that jumping is actually a little bit counterintuitive. Jump is going to like Well, maybe we should call it start jump, because it's just going to give the T-Rex some upward initial velocity, and then we're going to let the T-Rex update its own position over time without running this method again. Stand and crouch are how we're going to tell the T-Rex to change what image it's using to display. So maybe this is misleading, because stand, we're not really telling him to stand, we're really saying like load your own standing image. But like I said, we might rename some of these so that it's a little bit clearer later. Is on ground is a method where the T-Rex answers our question, are you touching the ground right now? And the reason that's important is we don't want to be able to hit the jump key multiple times and have him go jump, 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 like up off the top of the screen. If we hit the jump key and he's already in the air, we need him not to keep jumping. Like, he needs to go all the way back to the ground before jumping again. And so the only way we can do that is if we can ask him, are you on the ground? Because only the T-Rex knows his own position. Only the T-Rex knows what these variables are. So if we need to answer a question that has to do with those variables, the T-Rex needs a command so that he can answer that question for the game object. The last thing is we figured out it makes maybe more sense to do the collision detection inside the T-Rex, because the T-Rex could be hitting the Cactus, or it could be hitting the pterodactyl, or any number of other things that we add. So one version of this is we could ask the T-Rex if it's hitting a particular XY coordinate on the screen, or we could give it an XY coordinate and a width and a height. That would work, but in some ways it's a lot cleaner to just give the T-Rex the Cactus object that we want him to check whether or not he's touching. And then inside the isHitting method, the T-Rex can ask the Cactus, where are you, Cactus? And the Cactus will give us its own coordinates. So that seems like a very clean response. And then that command will return true or false. So we'll probably go back over these again, definitely these T-Rex ones when we implement it. But this is like a good starting place to be sure that we have a good set of behaviors for our objects that will let us make them do what we want them to do. So without further ado, let us now implement the Cactus class. Actually, before we do that, I'm going to have you download the template. The template doesn't really have any code in it, but it does have all the graphics that you'll need, so that's why I want you to download it. I'm going to walk you through this process step by step because it was a minor chaos when we tried to do this in class. So let's copy this URL, and let us now go to that location. And you see this little green button that says clone or download? Go ahead and download a zip file. Now don't open the file, but go ahead and go to the folder where it downloaded. This is probably your downloads folder. If you don't see a little button like that, it's okay. You can still go to your downloads folder in any way that you know how. So your display probably looks a little bit different than mine. Mine says .zip, and yours might not say .zip. But you should see either a little zipper icon or maybe a little lowercase z. And that's how you know that this is a zip file, which means that it's a whole bunch of files compressed into a single one. And we have to uncompress them into a folder so that we can use them. So go ahead and select it and right click, and you should see something that says 7-zip and say extract here. And what that will do, it didn't appear to do anything, but if I sort by name, and now I go up to my folders, it created this T-Rex runner template -master. Go ahead and copy this, and you need to put it in your Eclipse workspace folder. Where is your Eclipse workspace folder? If you put it where everybody else did at the beginning of the year, it is probably in the C drive, which you can get to by clicking this PC, and then the C:. And then it's in the users folder, which is where all the users are. And mine says D. Dobrovich. Yours is going to say like your kind of student user login. So click on that. And then, is mine the same place as yours? No. So yours has one that says, it says Eclipse-workspace. That's the one that you want. There's another folder that says .eclipse. Don't use that one. Okay, so let's pretend that now I'm inside my Eclipse workspace folder. I see all of my other projects there. That's how I know I'm in the right spot. And you can go ahead and paste your folder in there, and you should see TRex Runner Template Master. I'm going to rename this by deleting the dash master. I just wanted to say TRex Runner Template. If you go inside it, you should see an SRC folder and an Assets folder. If you see those things, you are in good shape. All right, so let's open up Eclipse, and inside Eclipse, make a new Java project, and you need to name it the exact same thing as the folder name that you just saw. So that's TRex Runner Template, all one word, no spaces, and each new thing is an uppercase letter. If you see this at the bottom where it says the wizard will automatically configure the JRE, that's how you know it's worked. If you don't see this, that means that you copied your folder to the wrong workspace or you named your folder the wrong thing. Okay, so let's finish. And you should see that it added a project here, but there's some red underlining, and that's okay. So the last step is, well, yeah, so go ahead and do this. Open up source and open up default package and double click on game, and you see the game here. It doesn't know about papplet because we have to include core.jar. So if you select TRex Runner and right click and go to properties, you can click Java build path and then the libraries tab and then add external jars. If you're lucky, you'll just see core v2. If you don't see core v2, you can try and search for it in the search bar. Otherwise, core v2 is located in the C drive. You'll see a folder that, well, I don't have it on my computer, but you'll see one that says processing libs. If you go into the processing libs folder, you'll see it there. So once you have loaded core v2, you can say apply and close, and all of the red should disappear, and now you're good to go. So let's go ahead and start making the basic things that we talked about. In the next couple of minutes, we're just going to make a cactus object and make sure that we can load an image, because that's something you've never done before, and I want to make sure you can do it. And then I'll leave it to you to add all of the movement and the other parts. So first, let's make sure we can draw anything at all. So I'll add a backgrounds 200 statement here, and I'll draw a line from an x-coordinate of 0 and a y-coordinate of 200, which is like the left side of the screen, to an x-coordinate of 800 and a y-coordinate of 200. And if we run this, we should just see like a horizontal line. This is going to be the background. Later on, we'll replace it with a better looking background, but for now, like that's the horizon line. Okay, well, like I said, game is sort of like our commander object. It's what's going to have all of the cactuses and the TRex and going to order them around. So let's make a cactus object. Cactus, my cactus. Remember, this is the pattern for declaring a variable. This is the data type. That's the variable name. And setup is sort of like the constructor. So this is where we actually create a new cactus by running the constructor. So I'll say my cactus equals new cactus, like this. Okay, and then we want the cactus to draw itself onto the screen. So down here in draw, I'm going to use the name of the variable, my cactus, and I'm going to say draw, which is me asking the cactus to draw itself onto the screen. Okay, well, this is underlined in red because we haven't made a draw method yet. So let's go ahead and open Cactus and do that. So here we are inside Cactus. Let's add the fields first. So we'll make all the fields private. So I know we'll need an X and a Y. I said we'll need an image for the cactus. So that's a P image. If your P image is highlighted in red, hover over it and say import. And then the last thing I said we needed was we needed a graphics window to draw the image onto. I'm going to call it screen, which is different than your handout. Your handout, this is called a window, but I kind of like the name screen better. Okay, well, all right, so let's make the draw method now. So down here under the constructor, we'll say public void draw. And if I'm asking the cactus to draw itself to the screen, we're going to use the screen variable. So let's right now draw the cactus as an ellipse. So I'm going to draw the cactus as an ellipse at its own XY coordinates, and we'll make it like 10 by 10. So is this a cactus? Definitely not, but we haven't loaded the image yet. So let's just make sure this works. So here I am back in game. If I run the game, I don't see anything because why? Probably my colors are wrong. So I'm going to hold the control key and click on draw. That's jumped me back to Cactus. Let's do screen.fill 0, which is black. Let's try it again. Nope. Good thing I tested this before I recorded the video. Oh, of course. I know what's going wrong. Okay, what's going wrong is I'm not looking at the console. Haha. If I scroll up the console, it's saying null pointer exception. And if I click right here, this is the line it's happening on. What it's telling me is I'm asking the screen to do something for me, and I have a screen variable, but right now this variable is empty because I didn't put anything into it. Right now, I've just created the variable, and it contains null. And that's what null pointer means. It means that this command, fill, is pointing at a variable that contains null, that's empty. All right, well, so where does the screen come from? If you notice game extends papplet. Ooh, and now you know what extends means. Extends means that this class is an extension of this class. So papplet is a graphics window. So I'm saying that my game class is an extension of a graphics window. So what I'm going to do is I'm going to use the keyword this as an input to the Cactus. This refers to the program that's running right now. So it refers to this game object, which is a graphics window. So I'm bundling up the graphics window and giving it as an input to the Cactus object. And so now inside the Cactus constructor, let's look side by side. Inside the Cactus constructor, I need to have an input that can hold this input that I'm trying to give it. So it's going to be a papplet variable, and I'm going to call it W for window. And now I can say this dot screen gets assigned W. Okay, now it should work when I run it. I'm just saving both sides so that the red goes away. So now I'm actually giving my Cactus a screen object, and then down here, when I run draw, I'm actually telling the screen to draw something. Okay, and you might wonder, where's the Cactus? Well, there it is way in the upper left because I didn't actually set its position. So if you wanted to, you could also set its position. This dot x equals 100, and this dot y equals 300. And so now when I run it, cool, now it's down there. Okay, let's replace this with an actual picture of the Cactus. So I got to tell you how to load an image. img is the name of the image variable. So I'm going to say image equals, and then you actually ask the screen itself to load the image for you. So w was my input variable for the screen. So I'm going to say w.loadImage. And now we need to give it a string that describes the folder and the file name that we want to load. So wait, let's go back over here. Inside TRex Runner template, you see this assets folder, and then there's all these images. So here's Cactus 1, which looks like that. So I'm actually going to say /assets, which is the name of the folder I want to be in, and then another slash and cactus1.png. So I've described to the computer where do you find the file that's the image that we want to be loading. So now I've actually loaded the image. And now inside draw, instead of doing this stuff, I'm going to ask the screen to draw an image using the image command. I'm going to give it this variable that contains the image I want, and I'm going to draw it at the xy coordinates x and y. So now when we run it, voila, there's our Cactus. I'm going to move the Cactus up a little bit now. So instead of a y of 300, I'm going to give it a y of 200. And that's looking a lot better. Maybe I'll even give it a y of like 150. Because I want it to look good. Yeah, that looks a lot better. Okay. So here's the problem. This isn't very flexible because right now I have one Cactus. If I was going to create a second Cactus object inside the game, it would be in the exact same XY position. So I don't want to assign numbers here. Instead, I want the person creating the Cactus to give the numbers as an input. So I'm going to provide so I'm going to put the 100 and 150 over here as two more inputs to the constructor. And now the Cactus constructor here should take x and y as inputs. And now I'm going to say this object's x-coordinate should be equal to that input x-coordinate. So remember, the keyword this refers to the object that's running this code right now. So this dot x in blue refers to the blue x-coordinate up here, which is the x-coordinate for my object. This brown x variable refers to this x over here with the box, which is the number 100, which was the number that got assigned as an input by the person who's trying to make the cactus in the first place. So we assign the 100 here, and then the 100 gets copied up as the cactus x-coordinate. Okay, your next steps, which I'll let you do, are to add cactus movement. So I'd suggested myCactus.move. I left out some of our fields, but we said we wanted a cactus speed. So you'd declare the variable up here. You'd give it the initial value in the constructor. If you want to pass it as an input to the constructor, that's okay. But myCactus.move should change your x-coordinate by whatever the speed is. And then probably you want to see if it's off the screen. So it might be nice to do something like this. If myCactus dot is off screen, something like that, equals true, then my cactus dot reset position. I'm just making up methods here, which we haven't written, but I'm trying to think about how would I want to order the cactus around. I want to ask it, is it off the screen? And if it is off the screen, I want to tell it to change its own position. So this is called programming by intention. So I'm writing down the intentions that I have for my object. And if this is going to work, now all you have to do is create these methods inside Cactus to make them do what you want. So over in Cactus, you can go ahead and create these methods. This one should return true or false. This one should return void, but it should change your cactus's x-coordinate, maybe to a random position. That's what you can finish up in class on Monday if you don't get that far. Otherwise, give it a try at home. Good luck.